Okay, how does this reaction progress diagram, what do I need to include with this one? Okay, so I've got reactants and I've got my products. So the reactants are at a certain amount of energy, and what has to happen during this particular reaction? Products have to have more energy. So the products are going to be up here somewhere. So I'm going to go into a transition state, and then they're going to fall back down here, but this line here needs to be above my reactants. So what's happening in this transition state area? What's this activation energy being used to do? So I got stuff bonded together as reactants, and then the transition state is the place where those bonds separate. The activation energy is what is used to separate those bonds. So in that humped area there, I've got a bunch of atoms that aren't happy because they need to make bonds. They just broke the ones, and so now they have to reform bonds, and so they can make products. Okay. Rate constant. All right. So for this one, it goes up by 2. This one, it goes up by 2. So it's first order with respect to the x. This one, it goes up by 2. This one, it doesn't go up at all. And what happens here? This is like 8.13 or something like that. So what order is it with respect to y? Third order? Because 2 cubed equals 8, and so that 8.1 is close enough to the 8 that we'll use that. All right, so how do I calculate my rate constant? Okay, so my rate constant is equal to my rate divided by my x and my y cubed. So I just pull any data set I want. So 4.3 times 10 to the negative second divided by 0.0014 times 0.08 cubed. So 0.04. Divided by 0.0014 and my 0.08 cubed. You get be like 4. So then that's your rate law there at the bottom. It's nines, all nines. So what do I need for my voltaic cell here? What is this? Magnesium and zinc. Okay. So which direction are the electrons going? Towards the magnesium or towards the zinc? Zinc? Really? Is the zinc above it? Or sorry, the magnesium's above zinc? Okay. How many electrons is the magnesium going to be giving up? 2. So 2 electrons are going to travel this way, and I'll have 2 electrons here, which is good because in this solution I'm going to have zinc plus 2s. And over here I'm going to end up having magnesiums with a plus 2 charge. Which metal is being reduced? No. I think you're confusing what is happening to the actual pieces of metal with the chemical term reduction and oxidized. So yeah, the magnesium bar is definitely disappearing. But when we talk about something being reduced, we're talking about the charge of that substance going down. So over here, my my zinc plus 2 is being reduced to zinc solid. And my magnesium solid is being oxidized to magnesium with a plus 2 charge. Which metal is the reducing agent? The magnesium is the reducing agent. What is happening to the magnesium? It's being oxidized, right? So if it's being oxidized, it's losing electrons. What are those electrons going and doing? Traveling over to the zinc ion, and they're doing what to the zinc ion? They're reducing it. So the thing that's being oxidized is losing electrons, so it must be sending its electrons to something else. So it's acting as the thing that's being the cause of the reduction in the other substance. Does that make sense? So I have something that's losing electrons. The only reason it's losing electrons is it's giving it to something else. So that means it's reducing. The magnesium is technically reducing the zinc, so it's the reducing agent. We'll do the voltage and talk about that a little bit more. What's the... Where is that? Nope, not what I wanted. So, is the magnesium written correctly here? It's not, it's written backwards. So the magnesium is going to be generating 2.38 volts. What about the zinc? Is this written correctly? It is. So, stop it. One 1.62 volts. Will electrons be transferred if you have magnesium metal and mercury ions? Is something going to happen here? How do you know that? How can you answer this question? So first, you should look and see who's higher on the list, and magnesium is higher on the list. So if I'm higher on the list, I have the ability to give my electrons to somebody lower on the list. Does the magnesium have any electrons to give? Yeah, it's a solid. And I also have to make sure that the thing lower on the list needs electrons. So does it? Yeah. So this reaction is going to happen. Has, needs, higher, lower. All right, how about zinc ions and copper ions? Anything happening here? Why not?
Both ions, right?
They're both ions. Nobody has any electrons to give. Sure, the copper needs them, and the zinc is totally willing to give them to it if it had anything, but it has no electrons to donate. Will they transfer with calcium metal and lead metal? How about this? Nope. Nobody needs any electrons, so nobody's going to take any electrons. The lead's lower and the calcium's higher, but calcium can't give the lead if it already has all the electrons it can hold. And we've got silver metal, and we've got sodium ions. Anything going to happen here? No. This is lower, so it won't transfer electrons to something that's higher. Okay.